I got dinner for the night.
What is it?
Passenger pigeon. You could have missed it. It almost completely darkened out the sky.
Oh. Where am I? What is this place?
You are in 21st century America.
How is that possible? What could I possibly have gone in the future for?
The passenger pigeon has gone extinct.
That's also not possible. I saw a huge flock of them today.
That wasn't today. It was almost a century and a half ago.
Even so, there's no way something so plentiful could have gone extinct in such a short amount of time.
One would think so, but no. Their numbers were once 3 billion or more, but that slowly dwindled down to just one. A bird named Martha in the Cincinnati Zoo who died on September 1st, 1914.
That's horrifying, but even so, what could I possibly do about it?
Well, let me ask you something. If you had the chance to be a part of a group working to bring back the passenger pigeon, would you?
Of course.
Hey, how'd you get it?
You left the door open. Is that a bantam pigeon?
Yes, it looks like a passenger pigeon, doesn't it?
Yeah, except passenger pigeons have longer tails and orange chests. What are you trying to do with it?
Combine the traits of a bantam pigeon with the DNA of a passenger pigeon. It's a perfect recipe for de-extinction.
De-extinction?
Indeed.
But how?
A fellow scientist has recently sequenced the DNA of a passenger pigeon, so now it's only a matter of splicing that into living cells of the band-tailed pigeon.
Well, if it's that easy, then why don't we just do it now?
It's not that easy. I'm sorry, I gotta take this.
You can't take that.
Is there anywhere I could go to find out more information?
Yes, the library. I'll take you there. I even got a few books for you.
From my reading, it seems like most people know about cloning. Cloning could bring back, for example, the thylacine, commonly known as the Tasmanian tiger. Although extinct in 1936, museum specimens of the species could provide feasible DNA. Once scientists have the DNA, the hard part is putting it into the whole genome. If they succeed, the next step is to actually create the specimen. From there are two routes. The first would be to combine the nucleus of a thylacine cell that was created in the lab with an egg of a closely related species. For the thylacine, it would be the Tasmanian devil. This would result in an embryo that would be placed inside the uterus of the Tasmanian devil. Journal 2, Reverse Engineering. Oh, so this is what the scientist at the lab was talking about with passenger pigeons and band-tailed pigeons. He wanted to reverse engineer the band-tailed pigeon to become the passenger pigeon. To do that, the scientists would have to match up the band-tailed pigeon's genome to the passenger pigeon's. Although, for it to truly be a passenger pigeon, it would have to look and act like one, which is the hardest part about reverse engineering. Scientists still need to figure out how an organism's genome render its behavior and anatomy. Journal 3, Breeding Back. Unsurprisingly, this is already being done. Scientists are trying to bring back aurochs, an ancestor of cows, back through this process. It involves specific mating to reconstruct the genome and anatomy of the animal. With this more natural process, the species would already be adapted to its environment. This process would really only need human aid when dealing with embryo placement and artificial insemination. Scientists will know when they are done when the DNA of the extinct species matches up with the new species. Now that I know all this information, what do I do with it?
Learn from it.
Wake up, it's time for breakfast.
I had the weirdest dream. What's for breakfast?
Eggs and passenger pigeon.
No!